In question 7a, we're asked to graph the transformation of a parent function of the square root function. So what we've been doing is we've been modeling this by putting in our parent function's order pairs in 3 of them. So if we put in just the square root of x as our parent function, then the square root of 0 is 0, the square root of 1 is 1, then we jump to square root of 4 is 2. We're going to use those order pairs to help us graph our transformed equation. So if we look at our equation, this x plus 3, that is our horizontal. We can always tell horizontals because they're inside of our grouping symbol, in this case the square root, and they're always counterintuitive. So if it says plus 3, we really want to take these and make them minus 3. So we want to subtract 3 from all the x values. So negative 3, subtract 3 from 1 is a negative 2, subtract 3 from 4 is a 1. And then we got 2 things that are being done horizontally. The 2 things that are going on the outside of the grouping symbols are the negative sign and the negative 2. Remember, the order of operations, GEM-DOS, helps us determine which one's going to be done first. So if we were to perform our order of operations, the multiplication and division would be done first, followed by the addition and subtraction, which would be done second. So the next thing we want to do is we want to change our y values because those are horizontal transformations. So I'm going to take all of the y values in our original parent function, and I'm going to negate them first because the subtraction would take first. So a negative 1 times 0 is still 0, a negative 1 times 1 is a negative 1, and negative 1 times 2 is a negative 2. We would follow that up with subtracting 2 from them because that's the second thing we have to do to y. So I'm just going to cross them out, and I'm going to subtract 2 from both of them, so it's negative 2. Subtract 2 is a negative 3, subtract 2 is a negative 4. And those are the order pairs that we're going to graph, the negative 3, negative 2, the negative 2, negative 3, the 1, and the negative 4. And that will be the path of our new function. So our color we can see. We want to graph the order pair negative 3, negative 2, the order pair negative 2, negative 3, and the order pair 1, negative 4, and it opens downward. So that's our graph. We're also asked to describe the domain and the range. The domain and range are really determined by this one point right here where our graph begins. It's the order pair negative 3, negative 2. So we know our x values have to be greater than or equal to negative 3 for our domain. And our range values, our y values, have to be less than or equal to a negative 2.